grade 12s, and welcome to today's calculus lesson. Now our topic for today is differentiation rules. Now there are a couple of differentiation rules that will make life much easier. Let me show you. The first rule says if I have fx equals to in the form of ax to the power of n, well, that means I have a coefficient of 7x squared, ax to the power of n, and I should differentiate it or get the first derivative of fx. Then what I need to do is I need to multiply the coefficient with the exponent, a times n. Write down x, and then I need to subtract 1 from my exponent. Let's see how it works in this case. I have fx equals to 7x squared. I need to write down the first derivative directly. No need to do first principles for now. What do? I apply this rule over here. I multiply the coefficient with the exponent, meaning 7 times 2 gives me 14. Write down x. Now I need to subtract 1 from 2 from my exponent, and 2 minus 1 is 1. And, well, no need to write down actually the 1, because anything to the power of 1 stays the number itself. So I'm just going to remove that 1. So the first derivative of 7x squared is equal to 14x. Now let's expand this fx a little bit and see what's going to happen. We have 7x squared minus 5x plus 4. Say for instance, that is my fx, right? What I do is I apply that rule exactly the same manner as what I've done with the first term in this case. So minus 5x. So what do? Minus 5 is the a, multiply by my exponent. What is my exponent? My exponent is an invisible 1 that is over there. So minus 5 times 1 gives me minus 5, write down x. Now I need to subtract 1 from 1, and that gives me a 0. And anything to the power of 0 is equal to 1. So actually no need to write down x to the power of 0. Okay? What happens to the 4? Well, plus, and actually what do we have here? We have an x to the power of 0. That's actually 1. Now let's apply this rule directly. So what's going to happen? We're going to get 4 times 0 is equal to 0. And if I multiply anything by 0, my answer will stay 0. So no need to write down that at all. No need to write that down at all. So the first derivative of a constant value is always equal to 0. Let's take another example. Let's say in this case we write down our equation as y equals to 3x squared minus 9x plus 2. Another way that we can write down our first derivative, or the notation for that, is if I want to get the first derivative of this, I can write it down as dy dx. Okay, we write it down as dy over dx, but we pronounce it as dy dx. Now, d stands for actually delta y, delta x. And actually, that is the gradient, okay? That is the gradient that we've learned so far. So, in essence, what this asks us to do is to get the gradient of that expression. But we don't call it the gradient. We're working with calculus, so we use calculus terminology. So we say the first derivative, that is the gradient, but we call it just the first derivative, dy dx. What is dy dx of that expression over there? All that we need to do is dy dx equals, because y represents that y and the x is that x over there. So dy dx, get the first derivative. We apply this rule exactly the same. So 3 times 2 gives me 6. Write down x, subtract 1 from 2, it is 1. Apply the rule here as well. So minus 9 times 1 only gives me a minus 9. And the x will fall away because to the power of 0 gives me only 1. And as we seen that any constant value, the first derivative of a constant value is always equals to 0. Let's have a look at another notation. Actually, that is the one that I like the most. And that is with a capital letter D. Differentiate towards x. That's what it says. Differentiate towards x. And we always use square brackets. Now let's make it a little bit more difficult to see what is the second rule that we need to apply to. And that will be x squared minus 5x minus 6 divided by x minus 6. Right, we want to jump into this thing and say, well, okay, right, let's differentiate on top divided by the differentiation at the bottom. No. If there's division or multiplication in my expression, I need to simplify first before I can get the first derivative. That is my second rule. So I need to simplify it first. So just remember this one. That is my first rule over there. My second rule. Simplify this expression. Now, how do I simplify? Well, I just factorize. So it's equal to, still differentiate towards x. I'm just writing that down. So the factors of that expression will be x minus 6, x plus 1 divided by x minus 6. Right, square bracket. Okay, so now we can simplify it quite nicely because we see that x minus 6 and x minus 6 cancels out. So I only have x plus 1. Differentiate towards x of the expression x plus 1. And that is very easy now. Remember, there's a 1 over there to the power of 1. So 1 times 1 gives me 1. X, and then subtract 1 from 1, and that is 0, so it will be 1. So my answer stays 1. Right, thanks. Let's clean the board, and then we continue just after this. Thank you for watching.